Hello everyone and welcome back at Coding Boost. Today we start a new series about the adventure of Coding Boost, featuring Guster, Master Max, and Expert Eddy. These three coding bots came across a castle and they were really curious about it, so they decided to go and explore it. As they were about to cross the bridge to enter the castle, they came across a bunny who introduced themselves as Bit Bunny. Then Bit Bunny said the following thing: "Do you want to know a secret about the castle? I can tell you if you solve the following coding problem." The coding bots were a bit confused as why would possibly a Bit Bunny want them to solve a coding puzzle, but they went along as they really wanted to know the secret. "Alright then," said the Bit Bunny. "Here is the problem. The bridge ahead of us can be represented by an n times m rectangle, and each cell is either safe or not safe. I know which cells are safe and which are not, and I can tell you this. And we need to cross the bridge by only stepping on safe cells. We can start any of the tiles on the top row since we will only step on the bridge. And from there, we need to move up, left, right or down in the bridge by only staying on the safe tiles. And once we reach the bottom row, then we successfully cross the bridge. And one more important detail which Bunny mentioned is that I saw several people passing the bridge. I don't remember exactly what path they went, but I do know that lots of them passed it, so it's definitely possible. And for the input, I will tell you the size of the bridge, and then I will tell you all of the cells, if they are safe or not. And for the output, I would like you to tell me the starting index of the first row that we want to step in to start our journey, and then you will need to provide the direction that we need to travel. The coding boost started thinking of this problem, and Expert Eddy spoke up first. "Well, I don't know the solution yet," said Expert Eddy, "but what I do know is that it's not worth to visit the same cell twice or more. The reason for this is if we visit the same cell 2 times, then the path that we went between visiting 2 times is completely irrelevant, and we could take out of this from our journey to keep it more simple." Master Max and Guster agreed with this reasoning, and then Master Max was the next one to spoke up. Master Max said the following thing: "Well, I think we need some kind of DFS function here to check all of the tiles that we can reach from one. So for example, if I knew that we can start from this certain position, then I will just simply make a DFS function and see which cells I can reach, and then once I reach the bottom cell, then I can guarantee that we can make the path, and then I will somehow figure the path out. But I don't know where we can start from, which is a bit problematic." And Guster said the following thing: "Well, you don't need to know, you can simply make a DFS from each of these top rows, which has a 1. Expert Eddy then asked, "Won't it result in a long runtime, since you have n of these starting positions, and each DFS can take up all of your cell, which is n times n, so you would be the maximum number to the power of 3, which is 1000 to the power of 3, which would be 10 to the power of 9, which is too long of a time limit, and Bit Bunny definitely don't want us to wait for that long." Then Guster said, "You would be correct, but there is only one difference, is that in the DFS we will keep track of the used array between DFS calls as well. So we will visit each cell only once. No matter how many DFS calls we start, we will only visit each of them once, since if we visited it, we won't even start the DFS there, and we won't enter any cell that we already visited. Meaning that our runtime will still be n times m, which is 10 to the power of 6. Expert Eddy was convinced with this reasoning, and they kept thinking of the solution. Master Max then said the following thing: "Well, I will go ahead and write the DFS code and take the input so we can start coding the solution. First of all, I will have a maximum size as Bitbury told us. I will keep it as 1 so we can index from 0 or 1 if we need to. Then I will have the string of the inputs that Bitbury will provide. Each of them will be a character of at most 1000, and I will have most 1000 of these strings. And then let's keep track of the used array as Grandcaster suggested. So we will save this array. And we will also have the add and m sizes as input. So inside of the main function, let's take the n and m values, and then we will have n strings that we will take from the input, which will represent the safety of the size. Alright, so then we can call the DFS functions, and then MasterMax was a bit confused and asked Grandcaster, how do you start from different ties from the DFS function? Then Grandcaster typed the following line. We will simply go through from 0 to m of all of the size in the first row, and if that row from the first row and that column is safe, which is represented by 1, as Bitbury said, and we also haven't used it in our DFS call, then we will make the DFS call. Expert then asked, how is it even possible to have this used value as true, since we just begin the DFS here? Then actually MasterMax replied instead of Grandcaster, as MasterMax already saw what's the reason for this, and told Expert Eddy that because we have this for loop, we will actually run these some of these DFS functions before we check the later used values, and we might reach one of the starting positions as a result from another starting position. MasterMax then took back the control of the computer and started writing the DFS function. So we will have two values, x and y, our current position, MasterMax. And we will want to go through all of the neighbors. So MasterMax came up with the following pattern. Let's go from x minus 1 until x plus 1. We will increase this value. So we will go when x-axis less than x is equal or it's bigger by 1. And we will do the same thing for y. So we will get all the neighboring positions, and here we will skip the part where x is equal to x and y is equal to y, as this is the same position. And we will also skip if none of them is equal, because we can't go in diagonal. And in the beginning, we will set the used x, y as true. And then here, if we haven't used x, y, and it's a safe cell, then we can go do the DFS for that. Grandcaster then corrected MasterMax and said this is all correct, but you forgot one more thing, is that the x and y can actually get outside of the bounds of the bridge if you were to be on one of the edges. So MasterMax then corrected the solution and added the following line. If x is less than 0 or larger than or equal to n, or the same thing for y, the difference of having m instead of n, then we are outside of the boundaries and we continue with our for loop, and we will only check these cases. Alright then, so now they thought, how do we know if we found the path. But for that, Guster had the following idea. Let's have the completed boolean, which is initially false. And we will set this true if we reached the bottom row. And then if we reached what we want to want the FS course, which we simply do by adding the not completed condition inside of this if statement. And then we will stop doing the VFS and we can get back to the solution. And down here, if we completed solution, then we can make the output. And then they had one more problem they had to solve. How do they get the output? Exploitative was the first one to speak up again and said, well, we know the starting position now because it should be the I value inside of this for loop. Master Max then said, that's correct, but we forgot one thing. Bitbunny said that we index the positions from 1 to m, and if you see in our solution, we index from 0 to m minus 1, so we should add 1 to the output so Bitbunny can see it well. Alright then, so we add one more. Then Guster also mentioned that this end line will flash the output, but since we only output one line, it can stay the end line, or we can put a line break. So they decided to keep it end line as expert Eddy suggested, since it won't change the runtime if you only output a single line. Master Max then suggested that after they are done outputting, they should terminate the program, so they don't output another solution again, since Bitbunny only asked for one solution. Now they thought long and hard, how can they get the path? Expert Eddy didn't know the solution, and Master Max was still thinking, and Guster spoke up. Well, we will output an answer string where we will store the path, which will be initially empty. And the way we will fill this answer array is by this DFS calls. Once we complete it, we know that when we complete it, we will be at the bottom row. And we will no longer have DFS calls. And the way it will go back on the DFS calls is it will always go back to the parent caller, whoever found that cell, and it will go all the way back where we started, which will be 0i. So the DFS calls will go back from the target cell at the bottom of the bridge all the way to the starting position. So we will just simply need to add the path once we completed it and then reverse the solution. So down here, Guster already typed the reverse function, since we will store the solution in reverse, and then here I did the following line. So if we complete it right inside of this DFS call, so it wasn't completed here, but it got completed now, then we will add the correct path to the answer. So if we increased the x value, that means that we had to go down for that. If we decreased the x value, that means that we had to go up. If we increased the y value, that means that we had to go right. And if we decreased the y value, that means that we had to go left. Expert at the next. Isn't it possible two of these are true? Let's say that x-x is greater than x and y is also greater than y. Then we would add two of these characters instead of only one. And then Master Max already saw why it's not possible and corrected, explicitly telling that here we already checked if both of them are not equal, then we will continue. So only one of them will be different. So we will have only one of these paths to add to the answer. And then when we add these characters, Guster continued to explain the solution. We will do it every time we finish with the DFS as completed, and we will give back our path, and in the end we will reverse it, so Bitbunny will know the path, and we can go ahead and enter the castle. They were really happy with the solution, so they took the example input to test it out, and had to build and run it. And they entered the input, and then saw that they got a correct solution. They were really happy and was ready to tell Bitbunny the solution. But Guster said, before we tell the solution, let's go ahead and make another test case to test out. As you can see, in this first test case, it's really easy, since we only have one of these paths, and only one in the beginning. So let's create another test case where we will actually have a bit more complicated route. So we entered and the solution again. Then Guster presented the following input. Let's say that we have 5 rows, and each of them now will have 6 of these columns. So let's say that we will have the first row to be 1, 0, 1, 0, 1, 0. So we will have more paths. Now let's count for all these possibilities. For the second row, we will connect these ones, so we can have the solution that we already checked with the DFS function, and we will actually have the solution from the other row. So we will have this part, like this, and here it will be all 0, so we can't possibly go there anymore. So you can see that the first 2 ones is not the correct solution, but the last one will be. And here we will have all of these 1s, 0s, and we will also refill a 1. And in the last row, we will simply have 1 down here. So the correct solution here should be to start at the 5th number, then go down, down, left, left, and down. So they start from the 5th one, and they go down, down, left, down. So they were convinced that the solution is correct and show it to Bitbunny. Then Bitbunny checked the solution and was also really confident that it's correct, and went ahead and input the path of the castle, which was 1000 by 1000 bridge. And their program outputted the solution. Bitbunny was extremely satisfied with their solution and said the following thing: since you've solved this problem so well, I will tell you the secret of the castle. It's ruled by a king called Coding King, who lives on the top floor of the castle, and whoever can reach that floor will be rewarded by 1 wish of the Coding King. However, you will need to solve previous coding puzzles in order to advance the castle. The coding boost thanked the Bitbunny and went ahead and crossed the bridge to the castle. And we will pick up the adventure of Coding Bros from here in the next episode. If you enjoyed this episode, make sure to like and subscribe so you don't miss the future episode of Coding Bros.